In this lesson, we're going to work with interval notation. A shorthand used to write set, often set with an infinite number of sets, is called the interval notation. For interval notation, we use a curly bracket, variables, and other symbols to express the set. Curly bracket is read the set of. This symbol is less than. We use this symbol also, which is less than or equals to. This symbol which is greater than, this symbol which is greater than or equals to, this symbol that means belongs to the real number or is a member of the set of real numbers, this symbol which is union, and this symbol which we read such that. So how do we use these symbols to make the interval notation? For example, we have a graphically interval notation and set notation. We have all the numbers that are to the left-hand side of this point, which is the point A. For interval notation, we say that this is x less than a, any value of x less than a. We write it in set notation. We say x such as x is less than a, and x is a real number. In this case, we have two values, a and b, and we are talking about all the elements between a and b, but not including a and not including b. When we have a hollow circle, that means that the boundaries are not included. So for interval notation, we say that is x greater than a or x is less than b. In set notation, we say the set of values of x such that x is greater than a but less than b, and x is an element of the real numbers. In this case, which is something different, we have all the values to the left of a and all the values to the right of b, not including a and not including b. So could be x is less than a or x is greater than b. In a set notation, we said x such as x is less than a or x is greater than b, and x is a real number. In this interval, we have that a is a value that is not included, but b is a value that is included. So to write this, we say that x is greater than a and x is less or equals to b. In set notation, we write x such as x is greater than a and x is less than or equals to b, and x is a real number. The fill in circle indicates the inclusion of the endpoint. The open circle indicates the non-inclusion of the endpoint. If the interval goes forever to the left, the set goes to negative infinity. For example, the interval is the set of numbers that are less than 3, including 3. How do we represent that? Graphically, it's from 3 to the left, going to negative infinity. You can write using interval notation x is less than or equals to 3, or you can write this using set notation x such as x is less than or equal to 3, and x is an element of the real numbers. One more example, if the interval goes forever to the right, the set goes to the positive infinity. For example, the interval is the set of numbers that are all greater than negative 5. Graphically, it's going to be from negative 5 to the right, going to the positive infinity. And we can write this using interval notation. X is greater than negative 5, but it's not including negative 5. You can write using set notation is the set of x such as x is greater than -5, and x is a set of real numbers. If the interval includes the boundaries, it's represented by filled in circles. For example, the interval is the set of numbers that are all greater than -3 but less than 2, including -3 and 2. Graphically, will be a line between -3 and 2 and includes both boundaries, the -3 and the 2. That's why we have a filled-in circle in both sides. Using interval notation, we say that x is greater than or equal to -3 or less than or equal to 2. And we can write using set notation x, such as x is greater than or equal to -3 or less than or equal to 2, and x is a set, is an element of the real number. If the interval does not include the boundaries, it's represented by empty circles. For example, the interval is the set of numbers that are all greater than 4 but less than 10. It doesn't say that they are included. So graphically, we're going to make a line between 4 and 10 with boundaries at 4 and at 10, but the circle is a hollow circle, which means it's not including the 4 nor the 10. We can write using interval notation as x greater than 4 or less than 10. You can write using set notation x, such as x is greater than 4 and less than 10, and x is a number. If the interval is from the set of integers, it is not an infinite set. For example, the interval is the set of numbers that are all greater than 3 but less than 7 and are all integers. Graphically, we just make dots in the points 4, 5, and 6 because 3 is not included and 7 is not included. So we can write the list of elements as 4, 5, and 6 into curly brackets, or we can use set notation saying that x, such as x is greater than 3 and less than 7, and x is an element of the integers.